Hello, guys. Um, Good morning, or good afternoon, or good evening, depending on the location you are in. So this is Jun Lee, your lecturer for ACON 320. Welcome to this class. Last time I discussed about syllabus, and today's official first lecture for this course. So today we're gonna talk about probabilities. Okay, let me share my screen. Can you see this screen? You just yes, right? I guess you can see this one. So this is the slide I'm gonna use for this course. So there will be 12 slides. As I discussed previously, this is the first class. Okay, so there are two common ways of describing data. One is a probability, which is this chapter, and the other is average or others. Let's say we are in Albany. So if somebody asks, okay, can you describe the GDP, of students in Albany? And some say, okay, average might be a good description, or some say maybe using probabilities or using maybe other standard deviation or variance, etc. Probably you have heard about those terms before or not, but these are something we're gonna mainly cover next few weeks. So first week we're gonna cover probability, and second week we're gonna still cover probability, which is conditional probability. Third week we're gonna cover average and median, etc. And the fourth week we're gonna cover variance or standard deviation, etc. So the corresponding chapter is chapter 1 and 6.1. Again, you don't have to have a textbook, but I highly recommend it. I mean, you don't have to buy most latest version. You can buy older edition at Amazon, like maybe less than $10 or $20 or something. So I recommend you to have those in shop. So what is a probability? Probability is an event such that the proportion of the time that the event occur. So when experiment is repeated many times. So that being said, okay, let's say you flip a coin 5 times, and there the result is like two heads and then three tails. And one can say, okay, so the experiment is something like you are flipping coin like 5 times, and the probability of like a head, it would be what? So I said that the number of a head would be, okay, actually, let me try to use board. I installed the board, and let's see whether it's working. So you guys see my, but I have another camera over here. So you see it, right? So it's pretty cool, right? So so let's say you did like 5 experiments. Like let's say you had like head, tail, tail, something like that. Then this the things you did 5 times are called experiment, and we are looking for probability of heads. Okay, out of 5, what would be probability of heads? I mean, the answer is easy. So this is like a number of heads over total. So total experiment. So that would be 2 and 5 or 40%. So that would be your answer. So it's not bad, right? So okay, let me share my screen. Okay, before do that. Okay. Okay, so coming back to the slide, so that was kind of like example, so these were the example. If you do 100 times, it but only has defective, or so out of 100 products, if 7 out of 100 are defective, then means your probability is 7%. So this is kind of like probability what we are learning. So this one I already did. So experimentation action that generate the randomness, like a flipping a coin, or roll a dice, or etc. So event is a set of outcomes from the experiment, like I showed over here. These are the events, a set of outcomes from the from the experiment, and the past, for example, coin toss is head or tail. So probability of neither head or tail is 0 because it's impossible, right? So if you flip a coin, you got to have either head or tail. So the probability of neither happen to be 0. But if this is a fair coin, then the probability of head is 0.5, probability tail is 0.5, or probability of head or tail is 1 because that got to be always. So it's interchangeable. Like, I mean, previously I said 2/5, or I said 40%, or 0.4, everything are the same. So it doesn't matter. So, this is an iClicker question, but we don't have iClicker, so I'm gonna just in the throughout the slides, I'm gonna ask a bunch of questions. So basically, what I want you to do is whenever you see the question, please pause the video and think what would be the answer. Then I'm gonna leave you the answer anyway. So I mean, this is a very good way of learning. Like I give you the question, you just pause and try to think what is the answer, and that way you understand better. I also tend to ask questions from this the slide question on the exam, so make sure you guys understand that. So find the one that is not a probability. So I'm going to leave you the answer again. I ask you to pause and think about it. So answer is D. Why? So from a dice, 6 comes with a 1/6 probability, right? But and these are, let's say they Michael Jordan drew 100 shots, but 83.5, or let's say 1,000 shots and 835 he made it. So this is kind of probability, and same thing is probability, but Dow Jones industry like index dropped this much. That is just fact, that is not a probability. So these are some examples. I mean, so chance of snowing tomorrow would be 30%. That is based on some, what is going to happen tomorrow, and checking the errors. I mean, the weathers would be your experiment event is okay more than an inch of snow. So that is something. These types of data is called time series. If you are going to take econometrics, you're going to learn more over there. Same thing, 70% of customer satisfied. This is like a 70 out of 100 customer satisfied. That is kind of a probability, but this is just outcome rather than a probability. That's why this cannot be the answer. So I'm gonna show you some kind of data sets later. I mean, these types of data, I mean, not exact same data set, but will be provided for your final project, So usually the columns are your variable name, and each row represents your observations. So this is actually very good examples you can think of. So for example, this is observation 1. The observation 1, this is from the survey. Like I said, I don't know whether you have a chance to do any kind of survey before, but they ask what is your gender, when did you born, etc. These are all from the questions from the survey. They say, okay, what is your race? And you said other, and what, where are you coming from? What is the region of the place you're staying? And you say Northeast, or what is your education level, or what is your income, etc., etc. So, but instead of, I mean, if you do the survey, there will be hundreds of papers. You don't want that happen, but you transform the data set into the Excel file, for example, XLSX, and then you analyze this data. So this is how you format the data set. So later, I'm gonna actually provide you some data sets. Anyway, so you're gonna see. Okay, let me actually see whether I have those data sets to share. Okay, give me a second. Let me try to find the data set. Give me a second. Okay. I want to give you some taste of the data sets. But I'm gonna talk this later anyway. So, but data would look like this. For again, the columns are your variable names, and each rows would be your observation. So actually the data I was about to show was basically over 700 university in the US. I have like admission informations and then proportion of full time or graduation rate, etc. So that would be actually your final project. But I'm gonna show maybe next class. I'm having hard time to find those data sets, but let me try to find why I cannot find it. Mm, okay, it's weird. Okay, but anyway, I'm gonna share later. Okay, so structured data is basically each row is your experimental unit. So that would be one person, so each row represents a person. Or if you're looking for another data set, it can be a one country or one company, depending on the unit you are looking for. So sample size, the data set, the example I'm using here is like a 5,000 or something. So it change, over time. And each set is observed value and each column is a variable. So keep in mind this data structure. So if you are going to work as a data scientist or data analyst or later, these are the types of data you're going to see a lot and a lot. So first thing is first, you got to understand what would be the data sets. So oftentimes when I ask us, I initially actually, like a couple of years ago when I taught this course, I asked a student to find their own data set for this project, but they actually, brought some papers like somebody actually used. So those are summary statistics, but they said this is data sets, but this is a kind of a data set. So after that, I tend to give my own data set to you so that you can save some time. But when you're working or when you go to graduate school, you got to find your own data set. So that would be another step actually. Probably in the econometrics, you need to find your own data set or something, but given we only have 3 months of this semester, so I tend to give you the data sets. So there are differences between population and sample. So for example, population would be the whole, all American born between this period, and sample is like 5,245. So someone said, would say, okay, what is a statistic? And statistic is basically try to guess the population parameters using sample. For example, I want to know average American, the income of American, but instead of asking like tons of, 300 millions of people, in the US, you just collect some sample, like you collect 10,000 people and try to average out income and see what would be the income, average income. So you try to guess using some sample, the population parameter. That is a statistic. And one of the purpose of this course, because in real life, you're not gonna get the whole sample, For example, if I want to know the GPA of your urban students, but I cannot ask like more than 10,000 students, but I say, okay, I'm just gonna ask like maybe 40 students, around me, and just ask what is your GPA, etc. That is kind of statistic or sampling method. So population probability is the true probability. So when something happened infinite time, for example, in the example over here I gave you, everyone knows that the probability of head would be 50%, right? Probability of a tail would be also 50%. But when I have only finite sampling, only I did 5, I get like a 40%. So, but that is not true, right? But that is a sample probability. So using sample, I got 40%, but using population, I would get 50%. That would be called population probability, and this is sample probability. So this is a probability implied by a sample, like I did 5 times. So later I'm going to discuss having a larger sample size is really important. Like if I have only 5 and there is a chance that the all had come up 5 times, then probability of tail would be 0, but that is not true. So you got to have a lot of huge sample size. So population probability is in the sense that infinite time. If you flip coin infinite time, you're gonna have 50 and 50. So that would be something I'm gonna discuss more about in chapter 3, but that is something you definitely need to keep in mind. So they could be different. I mean, sample could be different because of randomness. As I said, if you flip only 5 times, you have a chance to get all 5 heads or 5 tails, etc. So, so randomness is coming from the experiment. So frequency is actually quite important. Let's say you have this kind of data sets, and let's say you are working for a company, and they said you have a 5,244 sample size, and you want to show them what is your distribution to look like. Instead of you showing 5,244, someone might ask, okay, actually, what is the frequency? I mean, how many people are in north central or northeast or southwest? And these are frequencies. So you show total sample size in the bottom, and you show, okay, how many is, etc. So this frequency term is very important. Later, I'm gonna convert this to the probability. So how it's working is you divide 1139 divided by 5244. That would be your probability, or probability of north center would be. So basically, can I write over here? Yeah. Okay. For example, this is called probability. Probability. That would be basically for this one would be like 1139 over 5244. So that would be what. If you have a calculator, you can use it. Otherwise, wait 5 seconds for me to do it. Okay, 1139 divided by 5244. So 21.72%. 21.72%. So that is a probability. So based on these frequency tables, you can say, okay, the probability that somebody, the region of residence is north center is basically 21.72%. Okay, so similarly, you can find the probability of northeast or probability of south or west, etc., etc. So okay, so another way of showing that, okay, actually the benefit of using Tableau is coming from here. So I'm gonna show you a little later how powerful the Tableau is. You can do this kind of thing in a second. Okay, maybe a minute or so. You need to set a program, but you got the sense. I mean, for example, I mean, this is like you're looking at the numbers, but you can actually show the frequencies using, for example, the Tableau very easily. Like this is a histogram, for example, there are 11, about 11, how many was it, 1139, and something less than 1,000, above 2,000, etc. So you can show them using this histogram. So I mean, throughout this semester, I'm gonna show you how you can use the Microsoft Excel function, pivot table, etc. Those are very easily available, but this is something you can try your own. I'm not gonna show in the class, but for your own information, and very useful as well. But I'm trying to focus on Tableau because that would be something you can actually use a lot when you are looking for a job. So I'm gonna demonstrate that sometime next class or something. So this is another way of showing visualizations, so that when you're working for company, say, okay, so this many people are in north central, northeast, south, and I mean, when they are looking at this graph, say, oh, okay, most of people are south and second highest is north central. So this visualization is very important. I mean, this is also very useful. So depending on, what kinds of thing you are looking for. So, and sample probability, this is something we already did. So over here, probability is a frequency of event A over total number of sample size. For example, what I did over here is, okay, 1139 is a the number of frequency of north center, which is 1139 over total sample size, 5244. So this is how you can find the probability. So very useful tool. So try to remember what would be the frequency and probability. The difference is very, very important. This is particularly important when you are looking in chapter 3 and 4, because you're gonna analyze what is the average and what is the a variance, etc. You're gonna use probability a lot. So make sure you know the difference between frequency and probability. I'm gonna ask for sure this in the exam. So, and the summation should be 100%. So make sure you guys familiar with that. And this is another way of doing that. I mean, previously you said we did just number of people, but this is another good way, you know. I mean, although we don't know how many sample size from this figure, but you know, okay, about 40% are from South. I mean, this is another way of using the tool. So very, very powerful. So this is another types of multivariable analysis. For example, using star. I don't know whether you know star example. So New York State household a survey give the following result. Let's say, of course, these are fake. So income 500K or less is 80%, but income 500K or above is 20%. Oh, it's a lot. 20% of people make 500,000 per year. So I don't know. I mean, I just made up. So, and 60% of distribution owning a house and 40% do not own a house. Let's say these are some frequencies or probability you got from the data. The question is, okay, STAR, by the way, STAR is a New York State school tax relief program. To eligible for the basic STAR, one has to be own a house and make, you know, 500K or less. So these two should be satisfied. For example, they got to make less than 500K and got to own a house to eligible for that. To make a government budget plan, it's important to calculate the probability of those who are eligible for the STAR. So based on this, what is the probability of STAR eligible people? Think carefully. So I mean, this is a very tricky question. So think very carefully. Okay. Okay, so I'm gonna reveal the question, answer. So I mean, you might want to pause this and think twice. I know most of people say, okay, um, um, this is owning a house is 60% and income is 20, so 80%. Do you think that is true? Yeah, see. Or what if probability that okay, if that is the case, what is the probability that somebody is making 500K or no, actually, I was backwards. So what if somebody is making 500K or less, then it's 80% times 60%, that is 140%. That doesn't make sense. So because probably cannot be higher than 100%. But someone say, okay, this is 80% and 60%. Can I multiply? Mm, yeah, you're getting there, but do you think that would be true? So I'm gonna repeat the answer. So the answer is we cannot calculate it given the information. To calculate the probability, we need to know the probability distribution table, something like that. The reason why you cannot get the probability of the STAR eligible people is because this is independent probability. So because you are looking at distribution for the income and distribution of house ownership separately. So separately is very important in here because to get the probability that you are looking for, so to get the STAR eligible, then you got to own a house at the same time. You got to make an income less than 500K. So it's got to be happening at the same time, or we call joint probability. So we need to have a probability distribution table like this. This is called joint probability. Um, joint probability. You're gonna learn more about this in the second chapter, like next week. But this is something very, very useful, you know, joint probability. So we got to fill this one. So this is actually main highlight of the second chapter. So I'm gonna come back to this issue, but that means we got to have those two probability. But since we know this independent probability of each distribution of income, so we got to actually So since you are having those independent probabilities, you can still get some information though. So that would be actually like you can find the maximum possible eligibility and minimum possible eligibility right there. So how do we get this one? How do you think you can get this? So I'm gonna use those information over here. I'm gonna write this on the board. This is actually quite important. So let me try to write on the board. Yeah, I lost my eraser, so I got to use the paper tower. Okay, so previously I said, okay, so let's say probability of income, let's say I think I said 500K or less, 500K or less. So let's say income, I should be backwards, something like income less than 500K would be like 80%. So I'm just directly getting this. That means probability of income greater than 500K is 20%. Another information was probability of own a house is like a house would be 60%, and probability of not no house would be 40%. So I'm gonna talk about later, but this information you are getting this one from here, right? That is actually later we could, this is marginal probability. So these are marginal probability. Can you say clear? Let me change it. Oh, yeah, this one is much better. I should have changed the location of camera like that earlier, but this is marginal probability. Each of them is marginal probability, but something actually we want to get is joint probability, I said, right? So this is actually called joint probability, because that is something we actually want to have. So for example, this is like a 500K or less. So income less than this or income greater than 500K. This is a house, no house. So say the marginal probability is the probability of owning a house, but these are basically the probability of, I'm gonna just reduce this one like this. This is a probability of owning a house. So owning a house, and then at the same time, this is called intersection because that is happening at the same time, and income is less than 500K. So in English, you can say this is a probability of owning a house, and this is important, and your income is less than 500K. So it's got to be happening at the same time. So that is called, this N is like called this intersection. This is intersection. So intersection, I'm gonna talk a little more in the next chapter, but so I'm looking for probability of owning a house at the same time income is less than 500K. That is each of this, there will be 4 fields up over here. Those are for joint probability. That would be what? That is a probability of a house, and this is N, income greater than 500K. So both of cases, they are owning a house, no matter what their income is less than 500K or greater than 500K, right? So I'm gonna, to give more space, I'm gonna just say greater than 500K over here. So in these cases, no matter what their income is, whoever are belong to this category, they're gonna own a house. So that means this one is a probability of owning a house. So this is a very, very important concept, actually, because this is a probability of owning a house at the same time income less than 500K. This is a probability of owning a house at the same time income greater than 500K. So the summation of these two probability is called probability of owning a house because income doesn't matter in here. So this is called the marginal probability of gain, and each of them was joint probability. So summation of joint probability would be your marginal probability. So what did we say probability of owning a house? We said it's a 60%. So that means the maximum summation of these two numbers is 60%. The summation cannot be higher than 60%, right? So, and similarly, probability of not owning a house would be 40%. So similar reason. And I can say this is a probability of no house. I say NH. At the same time, income less than 500K. That is basically you don't own a house, but at the same time, your income is less than 500K. This is joint probability. And this is similarly, you still don't own a house, you know, but your income is greater than 500K. So that's why summation of this one would be probability of no house. In other words, because in this case, I mean, your income is either less than 500K or greater than 500K, but you still don't own a house no matter what happens. What happened in your income? So your probability of no house would be 40%. So again, that is marginal probability. That is a summation of that. Similarly, whether you own a house or not own a house, your income is still less than 500K, no matter what, right? So basically, this is what's happening. So in other words, summation of this one would be what is probability of income less than 500K. Because whether you own a house or not own a house, your income is still less than 500K, which we said 80%, right? Similarly, summation of you know, whether you have own a house or not own a house, your income is still greater than 500K. So that is income greater than 500K. That would be 20%. Importantly, when you check your numbers, the summation of these two numbers should be 100%. And also summation of these two numbers would be 100%. So when you get the answer, if this number doesn't add up to 100%, something is wrong. So this is another way of checking that. So this each of them is basically joint probabilities and summation, that's marginal probability, very important. Actually, this is a highlight of a second chapter. I'm covering a lot for second chapter, so it's going to be much easier when we actually get into the second chapter. And then given this factor, okay, so how do we get the range like we discussed before? So let me give you some hint. So I said the maximum, the summation of this would be 80%. And you know, this is what the summation of this one is to be 60%. So what is the maximum value it can get based on, you know, this information? It cannot be higher than 60%, right? So the maximum value you can have is 60%. But if this is 60%, because why 60%? That is 60%. That means this would be 0%, right? If this is 0%, because summation of this would be 20%, so it's got to be 20%. Again, I choose one number. You don't have to choose this from starting point. You can choose this from starting point. Because you can choose, okay, maximum would be 40%. I'm going to show that way as well. For example, if this is 60%, then it's got to be 60%. So this is a one range. This is a maximum possible eligibility because we are looking for somebody who own a house at the same time income less than this. So this is a maximum value. So because our focus was this, that's why we focus like that. So what is the maximum value here? For example, the maximum value would be basically 40% because summation of this should be 40%. If this is 40%, this is 0%. If it's 0%, it's 20%. And if this is 40%, maximum value you can have is 40%. In other words, based on this example, what you can get is, okay, the range of this is between 40 and 60%. This is just something you can extract from the data sets. So based on this, you can say your supervisor that, oh, I mean, based on this, some probability we can get, it's going to be between 40 to 6%, 60%. But to get exact information, we need to know that this joint probability or joint probability distributions. So that is something. Then your supervisor or whoever interview you might be very impressed and you can get a job. Yes. um, Basically, this is something you can do like this. I mean, so again, what you have gotten was basically a marginal probability, but based on this, because we know the structure of a joint probability, so you can get summation of a joint probability to be probability of this, etc. So since you are at home, make sure you spend a lot of time understanding this. I would recommend for this example only, please try to spend like 30 minutes or more. Because you guys are full-time students and I expect you to spend at least 3 hours for this course. So every week I'm uploading a new material and you got to spend like 3 hours to master the course. I mean, you, at the time you are listening this lecture, you think, oh, I understand, but later you might forget unless you practice. So I highly recommend you to practice, okay? The nice thing about this video is later you forgot about it, you can come back, but do not postpone learning this material because later you say, oh, I mean, since it's already recorded, so I can take it later, like in 2 weeks or something. But at the time in 2 weeks, you might be busy and you probably don't have time. So I highly recommend you to study, while I'm posting the videos, okay? So let me share the screen again. So that's why we get this maximum or minimum range. And these were the definitions. So marginal probability was the probability distribution of a single variable. Joint probability is the probability of distribution of multiple variables. We needed these definitions. So we don't know the joint distribution. That's why we only guess maximum or minimum values. So even if you know marginal distribution of two variables, you cannot recover joint distribution of that. So because you still got to know the joint probabilities. So this is another type. I'm actually demonstrate some kinds of this like later, maybe in 2 weeks or something in Tableau. So you will see how you get this. For example, I said you have like a 5,200 something data set, but how do you get, okay, this is like a 523 people are living in North Central, and then also they are female. And then 397 people are living in Northeast at the same time they are female. So this is kind of a joint distribution, right? So based on that, you can find the joint probability. How do you get joint probability? For example, this one, this is basically something I'm gonna show. That is a probability of a female, and so I mean, since I cannot get the u the upper shape, so I'm gonna say n, because n is equal to intersection probability of female and northeast. The person is living in northeast is basically how many people do we have? 397 over how many observations do we have? It does 5,244 or something, right? So this is how you get the joint probability. And this is how you get the joint probability of female living in south and female living in west. And if you summate that, then you can get probability of female. So this is again the joint probability of a probability of female. So this is a marginal probability, which is the summation of each of joint probability. So for marginal probability, we are looking for probability of female. So where they are living doesn't matter. So that's why we summate them. Similarly, probability of male is like that. Probability of west is a summation of this. If we are looking for probability of west, then it's gonna be what? So the probability of west would be 576 plus 644 divided by total number of observation, 5244. So that is the summation of the marginal probability, because we are looking for this. So you are looking for frequency table, but you got to understand the difference between frequency table and then the distributions. I mean the probability distribution. So if you have a frequency table, you can convert this to the probability table, right? So in exam, if I give you a frequency table and I ask you some fill out and convert this probability, or ask you to find some probability, it's easy piece, right? For example, you can convert like that. But in your Excel file, you can definitely using this pivot table function, but I'm gonna also show in Tableau, but please try to do that later. So what is the probability of female? I already discussed it, right? But try to pause this and then I'm gonna fill the gap. So I'm gonna leave the answer right now. So pause it before I leave it. So again, the probability of female is, it doesn't matter where they are living. So that is, I'm asking marginal probability. So that will be here. So you got to add everything. So 9.97 plus 7.57 plus 19.66 plus 10.98, which is 48.19. So it's easy, right? I already did that. And female living in Northeast, that is here, right? So that is no, okay, I'm not gonna reveal the answer, but please try to answer. I'm gonna reveal the answer right now. It's here, it's joint probability basically, right? So it's quite easy. So once you create that, you can talk about lots of things, you know. Suppose that at new SAV launch a target customer are either, the or is very important. Or is like a union in here. So for or is like a union, so you got to add or the probability. That is a hint. So based on that, what should it be the case? So you might want to pause the video, but I'm going to leave you the answer. So probability of female, which is here, right? So the upper case is summation of that, or people living in NC. So it's here. So you got to add all the probability here plus 11.75, and then set or northeast. So it's got to be like this. So I mean, try to think this intuitively in English. For example, if I'm looking for female living in northeast, then I say 7.57 because I'm saying N. That means it happened at the same time. So female should live in NE at the same time. But this question is like a female, but I mean, it doesn't matter. It happens same time, but or. So that's why you got to add the probability. So I'm looking for probability of female, which is summation of this top. This is like a 48% or something. And people living in NC or NE. So people living in NC is here, NE is here. But since 9.97 and 7.57 are overlapping between the two, so we are subtracting that. Something you probably learned in your high school, or I don't know, but that is something very famous. So, for example, if you are looking for, something I'm gonna cover next, week anyway. But A, this is a union. B, so that is like basically or. It's got to be happen at the same time. But this is a probability of, sorry, it's A and B. So this is and. So this is difference, but this is like a basically probability of A plus probability of B. I'm gonna cover this more later, but minus probability of A intersection B. Similar example, I mean, basically this part is intuitively, for example, if I come back to the example, intuitively I'm subtracting. I mean, I said I'm just adding this probability, right? Everything over here and then summate this. But I didn't add it twice for 9.97 or 7.57 because that is overlap. So intuitively, you already know these are overlapping. So that's why you do not add them out. But mathematically, that is how it's been done. So I'm going to fill the gap again. Don't worry. So this is a union, an intersection, complement. So complement, so far we talk about this one. So or is like a union and is intersection. This is A does not happen. So basically everything but A. So complement of A is like that. For example, if I come back here, this example, I'm saying this is a probability of owning a house. Then what is a complement of probability of owning a house. That is basically so complement of this. So complement of this is basically it's a probability of no, you are not owner, so no house. So in other words, that is based on the formula, it's going to be 1 minus probability of a house. So that is a 1 minus 0.6, or basically it's a 0.4 or 40%, which is equal to this. So think carefully. So I'm saying complement is A does not happen, or basically probability of somebody not own a house is a complement of this owning a house. So think carefully this one. So you can find what is the probability of a female, and and this one, that basically you can get the answer right away, but I want you to try. Please pause this video. I'm going to reveal the answer. So basically, probability of female plus this one. But note that probability of this one is not summation of this, because you got to subtract this. That's why it kicks in the formula I just shared. So this formula came up. So for example, I just said it's a probability of female, and union W is probability of F plus probability of W minus probability of F intersection W. You need to subtract them. So in this example, what I'm doing is like that. In this example, it's basically probability of female is what? 9.97 plus 9.5, 7.57 plus 19.66 plus 10.98. So that is a probability of female, right? How about probability of West? That is a 10.98% plus 12.28. But if we add them up, it doesn't match. It's not equal. So you got to subtract that. This is what? This was actually 10.98%. So you're subtracting the summation of that. This is mathematically found. So basically, you're deleting the overlapping here, because 10.98 is over here at the same time here. So you only got to keep only one. So that's why you're eliminating one. This is basically the formula, intuition of formula. So that was also from this mathematics. Okay, and addition rule. F union W includes all women and all people in the West, but this double counts the woman in West. So that was the intuition. So this is addition rule I just described. So you can also find the probability of S union W. It's not easy. I mean, you can do exactly the same thing, right? So I'm going to reveal the answer, but before that, always try it. So answer is like that. So this mutually exclusive is terminology that if probability of A and B equals 0. Let's say you went to the, do you think, for example, West and South are mutually exclusive because people cannot live in West at the same time South. So they are mutually exclusive because there is a probability of A intersection B equals 0. So I'm going to actually post this actually, I'm going to ask this question in homework so you can find the example that mutually exclusive. Try to think this carefully. So this is easy. So you can use several methods. What is a, for example, but before I do that, pause this video, but I'm going to reveal the answer. So what is the probability that a randomly selected person does not live in Northeast? So that is a complement, right? So you can either get 1 minus 0.1541, or you can just add the other three probability, because probability that people not living in Northeast is a probability of people living in North Central plus people living in South plus people living in West, or 1 minus of this, because summation is always 100%. So using complement rule, you can get it, or you can just add all three. So this is another example. Let's say smartphone market share. Let's say the Sprint offer a free app, but it does not work ever. What is the probability target customer of this event? So each of these would be your marginal probability. For example, 30% of people are using Apple, 40% are Samsung, and 18 others. And 40% people use Verizon, 42 AT&T, and 18 Sprint. So try to think this carefully. I'm going to leave you the answer. It's easy, right? Because what? Suppose that Sprint, we are looking for that, but it does not offer Apple. So we are only looking at Samsung and others. So you can look at just 10 plus 2. So 12% is super easy, right? So for this one, I'm not gonna actually go over, but you can take a look at this in detail. But it's exactly same thing. Reason I'm not covering this is it's part of also homework, but basically exactly covering the same thing. But if you guys after you read this, if you guys have any question, just let me know. Okay. Okay, then I will meet you guys in the following lecture. So if you have any question, always reach out to me, okay? The first homework is due February 5th, I think. So following the syllabus. And then, okay, then, yeah, good to have you guys in the course. Welcome again. Talk to you later. Bye.